In this video, we look at the demodulation of the conventional AM. This is at the receiver part. So after modulation at the transmitter, we need to do the demodulation at the receiver. At the receiver here for conventional AM, we do not use multipliers. We do not use it. As in the case of DSP SCAM signals, we use circuit. We have a diode, we have a RC circuit. This circuit is a very low cost circuit. The input of the circuit is the received signal RT. That equals to the modulated signal because we are assuming ideal transmission. Now in this figure, this is the modulated signal in a larger scale. This is a high frequency of the carrier. And you can see the envelope of the carrier, that's the message. I'm going to use red to illustrate the output of the circuit, and the blue, that's the input RT. Now at this time, the input is positive, so diode is on. When the diode is on, the capacitor is charging. So its capacitor is charging. The voltage right here, Z of t, is rising. So suppose it's rise to here. Pay attention at this point. When the input decrease lower than the output, remember this red is the output and the input is changing. So at this point now, the input start moving lower than the output. So the diode is going to be off. When the diode is off, the capacitor is going to be discharging to the resistor. So the voltage here is going to drop. So at the time the capacitor is discharging, this input signal is changing like here now. Okay. The signal is changing like here. And up to this point, you can see the input is higher, start going to higher than the output now. So the diode is on again, it's charging again. So it's charging. And at this point, you know, the input is moved lower than the output again. The diode is off and it's going to discharge. The capacitor is discharging. And at this point, you can see here, when the capacitor was discharging, this is the input doing. At this time, when the input is higher than the output, the capacitor is charging again. And it's just going on here. If I design this RC value, the capacitor value and the resistor value appropriately, then the output of Z of t, you can see the red, will follow the message shape closely. For the AM broadcasting industry, they can have many users buying the AM radio set very cheaply. So therefore, they can still make money even though at the transmitter, they transmit the carrier signal. So the carrier signal is here, is transmitted. So this one is added to make sure overmodulation is not occurred, such that the simple circuit as a receiver can detect the shape of the message. In the lab, we're going to look at the demodulation of the conventional AM. So first of all, we have to modulate. After that, it pass through a rectifier. It cut out this portion. This portion is cut off. It only has this upper portion. And then it passes through a low-pass filter. As RC circuits here is low-pass filter. And then we can detect the shape, the envelope of the modulated signal. And that's the message.